Hi all. In this lesson, we're actually going to look at a more complex function like a square and analyze it using calculus and see if there's any rules we can figure out. So we can start off with, f of x equals x squared, typical square. Because this situation is a little bit more complicated than line, I'm going to visualize it just so we have a little bit of kind of analogies that we can use. And so one situation I like to imagine is that we are building a square garden. Okay, so we have a square garden, we're building it up, and we're just going to grow some veggies in it, let's say. Now, we might build a garden, which is a 10 by 10, and we have it here. And if you look at it, there's a few things that we can tell, just from algebra, really, is that, okay, if it's a 10 by 10 garden, the perimeter would be 40, 4 times 10, and the area would be 100. Okay, that makes sense, but, we don't have a calculus level understanding, which we can bring in right now. So, you should probably be itching to kind of use your x-ray vision on this thing because you want to see how it's changing. So we can start off and say the perimeter is basically a function 4 times x, and the derivative should be 4. That means every time we increase x, we're adding 4 units of perimeter. And we can actually visualize that. If we take a look, whenever you have a function like this, or a square, whenever it gets bigger, you're basically adding little sections of perimeter and extending it. So when you make the smaller square into the bigger one, you can kind of take this piece, put it on the side, take this piece, put it on the top, and then kind of fill in the gaps. So every time you increase it, you're going up by 4. And that's essentially what this is saying. No matter what you have, every time you increase it, it's going to go up by 4. Cool. Now how about the area? Well, you can take a look here. So we can sort of x-ray the growth of the area, and we sort of get this pattern. And what's neat is actually the pattern seems to be following the odd numbers, because the first square is 1. The second sort of slice that we take is 3, 1, 2, 3. The next slice is 5. The next slice is 7. That's pretty interesting. And why is that happening? I'm not sure. Think about it for a second or a minute. You can pause it if you like. Ready? Well, my kind of intuitive argument is that, well, whenever we make a square bigger, we're basically adding a strip on the side and the top and the corner. So, it makes sense that every time you go up, it should kind of follow the odd numbers because 2x plus 1, that'll actually generate the odd numbers as x increases. And so every time you go, you're basically adding a slice on the top of x, slice on the side of x, and a little corner piece of 1. And that'll actually spit out the odd numbers as you go along. We can figure that out with algebra as well. We can take our df, take the difference between the new value and the old value, and when we work it out, we get 2x plus 1. So we found it out with algebra, or if you want to call it calculus because we're using df. Calculus told us that the difference should be 2x plus 1, and then we kind of visualized it. In arithmetic, we checked it, and it seems to be making sense. So that's pretty cool. We have 2x plus 1 is the derivative of x squared, it seems. Now let's kind of try to work backwards a little bit. So one analogy I like to think about is that, okay, you have your garden, but there's the local veggie mob. They don't like competition in the cucumber business. So they're actually scoping out your garden and trying to get a handle of what you're trying to do. They can't see your garden directly, but what they can see are the changes that you're making. So they know that you're ordering fencing, and they know that you're ordering topsoil. So let's say they kind of see that you're ordering a bunch of fencing. So every day, let's say you get 4 more feet of fencing being delivered. And every day you also get more topsoil, but it's following this pattern of 1, 3, 5, 7, 9, 11. Well, what can they figure out? Well, the kind of like the low-level thug, he might just add up, what you've done. So, okay, you've got this much fencing so far and this much topsoil. I don't know what you're making, but that's what you have. Now, the mob boss, he's a little bit more clever. He can actually look at the pattern that you're getting and deduce what shape it must have come from. So he might look at that pattern and say, oh, you're getting a constant 4 for your perimeter, and you're getting your topsoil orders, they're going up 1, 3, 5, 7, 9. Oh, you know what? I think he's building a square because x squared will behave in that way. So, again, there's 2 levels of understanding. The definite integral, again, is just getting the measurement. Okay, he ordered 40 feet of fencing. But the indefinite integral is saying, oh, but you know what? That actually came from x squared. He's building a square. So the mob boss has sort of this more subtle understanding than the henchman would. And in the article, we'll talk about sort of some ways to get even deeper insights there. But let's just kind of wrap it up and make our little rule right now. So clearly, it seems that d over dx of x squared, well, that should be 2x plus dx. Last time we had 1, but if we leave it as dx, we can work it out and do the algebra. and we get 2x plus dx. So let's just plug it into the computer, take a look, derivative of x squared. Oh, wait a minute. We got 2x plus dx, and Wolfram Alpha is saying it's just 2x. And I mean, is that a typo? I'm not sure, but isn't the difference that plus 1? Isn't there a corner piece as well? I mean, we should count it, right? Wait for the next lesson and we'll find out.